my name is Esa Zarenturk. I'm the Education Manager at Sydney Quantum Academy. I've said hello to a few of you in person, and I look forward to meeting more of you after the presentations. Before we go through my slide, I just wanted to do an acknowledgement of country. So I'd like to acknowledge the traditional owners of Australia and recognise their continuing connection to land, water and culture. We're currently on the land of the Gadigal people of the Eora Nation, and I pay my respects to their elders, past, present and emerging. And I further acknowledge the traditional owners of the country on which our online attendees are on, and pay their respects to the elders, past, present and future. So you're all here to learn about quantum tech, but what is quantum tech? You would have heard about quantum computers, but did you know that there's other quantum technologies such as quantum sensing and quantum communications? There's many applications here. We talked about quantum computing, and I've spoken to a couple of you here in person about various applications, but here we really list a few of them. So we've got health, that's sort of drug discovery, medicine, but it's also can be applied in things like environment, so carbon reduction, global warming, and transport and infrastructure for optimization of transport routes, defense and cybersecurity with secure transmissions of information, and also in finance, so portfolio optimization for detection. So basically any industry you can think of, quantum technology can be applied there. So what about Australia? How do we fit in here? So in Australia, we have many organizations that are starting to recruit talent in quantum. And what I mean by that is people who know quantum, people who can develop quantum technology, people who can apply the quantum technology. They're looking for people like that, and that could be you. And so some of the organizations that are starting to recruit, you would have seen by now universities such as the USP partner universities and also other non-universities in Australia, for example, in Brisbane and Melbourne as well. And also some research centres such as CQCT and ECLIS as well. We're starting to see big tech such as Amazon, Microsoft, IBM. These are just some examples. And then smaller startups. We have them here in the quantum terminal. For example, Quantum Brilliant, Quantum Labs, Selecting Quantum Computing. These are all small organizations that are devoted to building a quantum technology to prepare us for the future to be applied in many different areas. So these are some of the examples. They're not only developing the quantum technology, but they're starting to apply it in various organizations as well, and they're adapting the technology. So for example, government isn't necessarily developing the quantum technology, but they're looking to adapt it. And you can look up some of these examples on our website. We have the job listings of all the different places that are starting to recruit for quantum talent. I'll also just mention that it's not just the sorts of companies that are starting to build the quantum technology, it's also things like consultancies and banks. They're already looking for people like you. They're looking for people to adapt this technology to advise them on how to use it. So Sydney, why Sydney? Why not anywhere else in Australia? Well, one of the reasons is we have one of the highest concentrations of quantum experts in the world. And what does that mean? It means we have people who are global leaders in various technologies in quantum, in various applications like software and algorithms. They live right here in Sydney. One of the best places to learn quantum. And yes, I'm giving it a plug here to Sydney. So what exactly is the Sydney Quantum Academy? It's a partnership of 4 of these universities in Sydney. That's UNSW Sydney, Macquarie University, University of Technology Sydney, and the University of Sydney. Macquarie University, I think. And we're backed by the New South Wales government. So that's really important. We're a little hub here in New South Wales, and we have 4 universities based in Sydney. And our whole goal is, we're not really developing the technology. That's not us. That's our universities and our partners. But our goal is to really invest in the new quantum leaders and to help build the quantum economy in the future. So that's you guys, online and in person. We're here to help you, to make you the leaders of quantum, because it's going to be you adapting to it and using it in the future. And so how do we do this? We do this through education, through scholarship programs, through schools outreach and industry engagement. So all those things are kind of what we do. And if you're interested, you can come and talk to us at the SQA booth after these talks. So what about some of our programs? So our programs are really there to sort of help you move forward. So for example, for our PhD scholarships, we offer competitive funding. So this is in terms of scholarships or stipends. They're quite competitive. And we also offer career development funding, which means that, if you want to go and you want to learn something new or travel for a conference, we've got the funding for that. We also provide access to quantum courses or quantum studies. So even as a PhD student, you're not just in the lab, you're not just in your research group, but you can go and take study across any of our 4 universities. If you want to learn more about quantum algorithms or quantum applications, you can do that. And we also offer seminars, workshops, and networking. So I know a few of you have asked me about jobs and applications. That we actually list them, how much you'll earn, what areas you're into, and what you need to study. So look out for that. You can also learn more by going to our University Open Days, which is in September and August. I've got the dates up there. There you'll learn more about quantum and the specific degrees, and you'll see some of our ambassadors there as well. We also will be at the Australian Museum for National Science Week as part of the Sydney Science Trail Expo. That's on the 15th and 16th of August. So if you're online, you've missed it, you haven't seen our exhibits or some of the demos, I encourage you to come to that. We'll have some of our demonstrations there as well, and you can ask us questions about the Sydney Quantum Academy. And lastly, we have a careers fair coming up in February next year. This will be as part of our conference called Quantum Australia. There you can actually hear from people in the industry talking about what kind of skills they need, what kind of jobs that they're recruiting for, and why they want you. So that's a great place to learn more about careers. And lastly, I highly encourage you to visit our website. We list all the quantum degrees, the units of study, and we link you to the different partner university websites. And we also talk more about our programs in general. So if you're interested in learning more after this session, I encourage you to go to our website. We have much, much more coming in the next couple of months. So I encourage you to follow us on social media or us actually both to follow us and join our newsletter. So you can use that QR code or go to our website to join our newsletter. So our next presentation is from Irene from UNSW. She's a PhD student, and I'll pass it over to Irene.
Hello. Thank you. Welcome, everyone. My name is Irene. Really quickly, I'm going to do an introduction of myself and what I do and how you can get to where I am. I'm leaving my details here just in, does this work? Awesome. I don't know if people in, oh, okay, yeah. Oh, I'm leaving my details here just in case anyone has any questions. Please shoot me an email. I'll be more than happy to answer your questions. And yeah, so how did I get here? I am doing a PhD in quantum computing at UNSW, working at the group of Andrea Morello. And I got here because I studied physics in 2000 and, well, a long time ago. And after that, I decided that I wanted to do a career in quantum because I thought it was really cool. So I moved to the States for a little while to work in something completely unrelated, but still quantum. I was working in optics at a research lab in California. And then I decided that I really like research. I wanted to keep going, and I wanted to start a PhD program. So then I moved to Australia just because of what Esther just explained. Sydney really has a hub for quantum computing and quantum technologies. So I thought that was a really good idea. And here's where I spent the last 4 years of my life, having a great time, meeting really good people and doing cool science. So if this is something that you're interested in, how can you get a career in quantum? Well, if you are in high school right now, which I think most of you are, you probably want to choose some courses like math or chemistry or technology. Anything related with numbers and science will be really helpful for later on. If you like these topics and you want to keep going and you want to study something at university, I can only speak of UNSW because it's the university that I'm working on at right now. But you have few options. You can get to do quantum computing research by choosing either of the 3 options that I'm showing here. You can do a Bachelor of Engineering, which is actually a new bachelor that we have. It combines both electrical engineer and physics, quantum physics in particular. You can also get to do some quantum computing research by choosing a Bachelor of Advanced Science with honors in physics, or you can do a Bachelor of just electrical engineering with honors in physics as well. And if you do that and you feel, oh, this is really cool, I got a little bit involved in some of the research groups that we have. I want to do research at UNSW. I think it's a really cool university. I want to do a PhD. You have a really many options to choose from. Like we have a lot of research going on at UNSW. Here are some of the examples. We have the Center for Quantum Computing and Communication Technology, which is where I work. There we work with silicon doing and building quantum processors. We have what used to be like a startup when I started, but now it's like a bigger startup. And like, yeah, I don't know if it's a company already. I'm not sure. But yeah, you would have the Silicon Quantum Computer with Michelle Simmons. Maybe some of you know her. And we have this new startup, which is called Dirac. They do the same stuff. Yeah, they also work with silicon, but they just transfer their technology to make it available for the industry eventually. And you have also other quantum technology centers like Fleet. They do more like material science and low dimensional quantum systems. So it's more of like a science research center, because all the rest are more focused on the engineering part of quantum computing. And why UNSW? Well, I chose 4 reasons why I think UNSW is a good choice of a university. The first one is because we really do cutting edge research. Sorry about this. I don't know why my presentation is showing these weird titles, but basically, yeah, here cutting edge research. All of our research is mainly, well, not all, but like most of our research is really has a real impact in the world. And you can see this by having a really high impact publications. You might not know this journal, but this is a very high impact journal, like a very well established journal in science in the world. And we also have fantastic research facilities. We have a center, the Australian National Fabrication Facility, where we can fabricate all our qubit devices. We have a really great labs to do so. And we also have a bunch of cool labs where we can test our devices and do our research. Also, I think it's a great campus. It's a really beautiful campus. It's really well located, and it's a very inclusive university. And I think we're the only university that has actually a quantum society. So that's pretty cool. You can really get involved at the very start of your degree. And also we have amazing teams. So here I'm showing my team, which is really awesome. But in general, like the community is just very special. And you might be wondering, okay, I really find quantum cool, but like, where is this going to take me? And what I'm showing here is just this really cool wheel that I found on Twitter, which shows all the quantum, or not all, but like a lot of the quantum research that is going around the world. And you can see that it is divided in different ways of doing quantum computing. I am working here in the spin quantum dot field, but you really have so many options around the world, and way more to come. But after my PhD, what I could do with what I've learned so far, I could either stay in academia, which is where I am right now, just doing fundamental research and becoming a professor and like being connected to university and to students, or you could really transfer to industry. There's so many industry options, and once you're in industry, you can either work with research and development, you can do consulting, you can be a software developer, you can be a project manager, et cetera, just in the quantum computing field. So I think that's all I wanted to say. If you have any more questions, I'll be happy to answer them.
Thank you, Irene. That was great to see. And I love this, Will. This is, for some of you, this is all your answers right there, all the different applications and different technologies. We're going to go to Jacinta now. Jacinta is one of our undergraduate students studying at the University of Sydney. And so you're going to hear about more of her experience in the Sydney Quantum Academy.
So hello there. My name is Jacinta May. I'm an undergraduate, as you heard, from the University of Sydney. I also did an SQA Summer Research Scholarship earlier this year, and that was actually at UNSW, but for this talk, I'll be sticking to Sydney. I'm actually a Bachelor of Advanced Science student. I major in physics and chemistry. And yeah, I just want to talk a bit about the quantum landscape at Sydney. So I'm sure you have all seen this iconic sandstone monolith that is Sydney University. It's gorgeous, and before I came to Sydney, it was one of the reasons I wanted to come to the campus. So here are some of the labs, the remarkable labs that operate here. And I want to go a bit into my personal journey about some of the research I've done, because as I say, I'm only an undergraduate. But the thing I want to impress upon you all as undergraduates and high school students yourselves, you don't actually have to wait until you are a PhD to do actual valuable quantum research. We can't let the PhDs have all the fun. Undergrads can get on the action too. So that's what I'm here to impress upon you. You don't have to wait. There are opportunities everywhere, and I'm going to show you how to do that at Sydney. So some of the labs I want to talk about today are the first three here: the quantum control lab, quantum integration lab, and the quantum nanoscience lab. So let's get to it. In the summer, I did an EQUIS summer undergraduate scholarship with the quantum control lab. So this is headed by Professor Michael Biersick. He's the director of the lab. He's also a CEO of a quantum company in his own right. It's called Q Control, as you've seen there. And this lab is based in trapped ion. So if you've been floating around the booths, you've probably seen the ion trap demonstration in the Sydney Uni booth. I recommend you see that if you haven't already. That's the basis of the technology that's used in this lab. And the experiments here require absolutely ultra precise timing. So my job over the summer was to design and build a circuit board that is able to coordinate and synchronize elements of a laser setup. So that was my job for 6 weeks. The great thing about this project was I got to put my name on the circuit board, which means that it's forever immortalized in the quantum control circuitry, which is a pretty great legacy for an undergrad, in my opinion, I think. So that was a lot of fun. Now, so this is the quantum integration lab. So for an entire semester, I undertook something called the Special Studies Program, which is something you can do at Sydney Uni. You can elect to do it alongside a physics course or a physics subject. So it means for an entire semester, I was able to play with ostensibly quantum crystals and have it credited to my degree, which was very important at the time. It's a good bonus. So the Quantum Integration Lab is headed by Dr. John Bartholomew. And for the duration of the semester, I was basically simulating how we can shine light from lasers into crystal cavities. So the interaction between light from lasers onto very, very special crystals will probably one day form the basis of a quantum internet. So that's what I was doing for that semester. Now, so this is the Quantum Nanoscience Lab, very, very dear to my heart. I love this lab with the fiber of my being. It's I've been working in it since I started in undergrad, and I've done extensive work here. We do a lot of different things, from topological materials to superconducting qubits, all the way to quantum dots. You know, there's everything in this lab. So this is headed by Professor David Riley. He is the director of the lab and also the director of the Microsoft Quantum Computing Contingent at Sydney, which means that we have a lot of money to do a lot of exciting things. So in this lab, I'm sure, so if you've actually been in the Nanoscience Hub at any point, you may have seen this yellow room. It's actually called the clean room. It's just, if you go into the lobby, it's behind the glass wall, you'll see a big yellow lab. That's actually where we fabricate, what's called fabricate, which means just to make the quantum chips themselves. There's a lot of intense work that goes on in the clean room labs. This image, of course, if you are anyway interested in quantum, I'm sure you're familiar with this one. The golden chandelier, it makes for perfect photo opportunities. And it's actually, to give it its formal name, it's a dilution refrigerator. And it does what it says on the tin. It makes things very cold. It's a refrigerator. Makes things extremely cold, actually, colder than space. And this is where the quantum chips that we make from the yellow room live when we want to see them do their quantum dance. And this last image, this is a micrograph of an actual quantum chip that I fabricated and made myself from scratch. So I think it's pretty exciting. So that takes you through a little flavor of some of the labs at USyd. Of course, this is a very, very small cross-section. Remember, there is so much more. I haven't even touched upon the quantum theory groups or the nanophotonics groups. Unfortunately, there's only 4 years in an undergraduate, so I can't exactly sample them all, but I can damn well try. These are also some of the degree pathways that you might choose if you want to go into quantum research later on. And if you want to speak to us later about any of these, or if you have any questions, feel free to come over. We're friendly. We'll talk to you at the booth. Thank you.
Really inspiring. And, you know, if you're interested in studying quantum or doing research as an undergraduate, Jacinta's a great person to talk to. So we're now going to go to Jason from UTS, and we're going to hear from his experience. Jason's a PhD student, and let's hear about Jason's experience.
All right, thank you. Hey everyone, my name is Jason Gavriel, and I'm halfway through my PhD at UTS. In high school, I studied extension 2 mathematics. I studied software design development, physics, and engineering studies. I ummed and ahed about what I was going to do in university for the longest time. And eventually I didn't really pick anything specific, a very broad double degree. I did a Bachelor of Engineering in ICT software, and I did a Bachelor of Science in nanotechnology. I graduated from that with an engineering internship, and I ended up getting a graduate position as a software engineer. During my undergrad, I studied and I enjoyed cryptography. I also learned about computer science, and I was a little bit envious of all of the pioneers in computer science back in the 30s, 40s, 50s that got to make lots of breakthroughs. It seemed like there was so much room for innovation. I was interested in quantum computing at the time, so I attended the Quantum Computing Summer School, a series of lectures in 2018, and I vaguely followed along. But what I found really exciting was there seemed to be so much new things to discover and research. It was a new frontier of computing. I worked as a software engineer for a bit, which was all well and good, but I didn't find it quite fulfilling, and I wanted to contribute something to science and return to quantum computing in the end. I reached out to some people in the field, and to my surprise, pretty much everybody responded to me, and they all had a resounding do a PhD. And it was funny because only a year or two earlier, I had sworn that I would never do a PhD because it was a waste of time. Spoiler alert, I did actually take their advice. That's why I'm here today, and I don't regret my decision in the slightest. Let's go here. Computer science is at the core of the research and the teaching teams at UTS. We are the top ranking university in computer science by many different measures, and you can find that information on our website. I believe a big part of that has to do with the experts which UTS has at its centers and the experts which we collaborate with. We work with industry leaders such as Google, Boeing, Baidu, Rigetti, IonQ, and Zapata, which is awesome for someone like me because A, it means that I get to collaborate with people who work at in these companies for exciting work on my PhD projects, and B, because once you graduate from your degree or degrees, you want to get hired. And it's a lot easier if you know somebody who works there. This is a neat diagram over here of what the full quantum stack looks like, ranging from high-level applications and algorithms to error correction and instruction sets, all the way down to physical qubits, which, by the way, UTS is mostly a software and theoretical centric university, but we do have a hardware lab working on superconducting qubits. I'm sort of near the middle of this table where I work on quantum algorithm design and analysis. But in reality, this is more what it actually looks like. All of the different layers are intermingled. And while I started off looking at quantum algorithms, I ended up branching into quantum programming languages and quantum programming environments. I also do a lot of work in quantum error correction, which is probably my biggest project at the moment. My research has become very multifaceted, and it's an aspect which I really love about QSI and UTS. All of the buildings at UTS are newly built. They're modern facilities, which is a plus. They're right over there, which is right next to Central. So it's a really convenient location next to the city. And there's a plethora of social and academic societies in STEM and other areas. But why quantum at UTS? Well, quantum software development is going to be a big thing, and UTS understands that. And it's training people from day one to build the underlying technology and to work in this field. This last slide here is a quick overview of the quantum information science major and some of the subjects which you may take as part of this degree, a part of this sub-major. And there's a huge amount of subjects here. Pretty much none of these were available when I did my undergraduate, so you're really spoiled for choice now. And yeah, Mick, Luke, and myself are at our booth all day, and we're here to talk. If you have any questions about the degrees at UTS, if you want to know about the student life, the experience of studying there, undergraduate or postgraduate, or if you just want to chat and play with the cool wooden computer that we have. So yeah, thank you.
So that was a great talk and a great sort of view of how you can do research and study at UTS. We now have our last presenter. It's Zixin from Macquarie University. Zixin is a postdoctoral researcher, and you'll get to hear from the next step up. So this is after your PhD, and if you decide to do a career in quantum at the universities. Here's Zixin.
Thank you, Esther. So my name is Zixin Huang. I am an SQA postdoctoral researcher at Macquarie University. So what that means is that I've actually done my PhD, and this is how I got there. I work on large baseline quantum enhanced telescopy. So I do research in quantum imaging, which aims at using quantum techniques such as entanglement to enlarge the baseline of telescopes. So I designed the next generation of quantum technologies to go in telescopes arrays in order to image into optical domain. Here's our team at Macquarie University. We have a range of amazing expertise. So we have Dominic Berry working on quantum algorithms and quantum metrology. He's actually directly funded by Google. So apparently there are about 3 main applications of quantum algorithms for doing quantum chemistry simulations, and his algorithms underpin all of them. We have Gavin Brennan, who's doing computing, sensing, and simulation. We have Daniel Bulgar doing quantum control. So he studies using techniques to control these atoms and spins on a microscopic level. So there's Alexei, me, once again doing quantum sensing, quantum control. We have quantum photonics, and we have Daniel Turner, who's doing relativistic quantum information. So he looks at black holes and how quantum information can come into play. And then you've been hearing from Cyril at our booth, who's working with Thomas Volz on shiny quantum nanodiamonds. So here are some of the pathways at which you can study quantum at Macquarie. So typically you would do a bachelor in science in either physics, maths, or computer science. And then what our program differs from the other 3 universities that we offer a research in master's by research. So that is a 2-year program as opposed to the 1-year program in honors. So that does give you a bit more time to explore your interest and take a bit more coursework. And so one advantage that gives you is that if you are thinking about doing a PhD, especially if you want to do a PhD overseas, so I'll be honest here. So the Ivy Leagues in the US and Oxford and Cambridge take our best graduates every year. And if you want to prove that you are the best, you show that you can do real life research, and that's by getting your name on a publication. So if you can do a master's in research in science, that gives you 1 more year to get your name on a paper, a publication. And then you can pursue your PhD or here or elsewhere. So please come talk to us.
Thank you, Zixin. That was great to hear about sort of postdoc experience and also how you can learn more about quantum at Macquarie. So now we're going to do a panel where you have a chance to ask our speakers some questions. If we don't get to your question, always give us a buzz on our email. Just go to our website. You'll find our email there and send your questions through there if we can't answer them. So I'd like the speakers to come and join me on stage. All right. So to kick it off, I'm going to ask a very broad question. Is it on? Can you hear me? Yep. Okay. I'm going to ask a very broad question to all of our speakers, and that is, why did you choose to study quantum? So who wants to start first? I might start with you, Jacinta.
Sure. I chose to study quantum after falling in love with it at the age of 15. I remember an open day that I went to at UNSW, Michelle Simmons was putting on. I watched electrons populate a cavity and I was like, that's it. So after I graduated, that's all I wanted to do. So that's how I got into where I am now.
And for those who don't know, Michelle Simmons is a superstar in quantum. So great researcher based at UNSW, CEO of Silicon Quantum Computing. Go look her up. She's amazing.
As I touched on in my talk, I wanted to contribute to the field of computer science And when I discovered quantum computing, there just seemed to be it was a new frontier, and there's so much that you can do to contribute in all these different sub areas. It's such a wide field, and there's so many things that you can do to innovate in that field. And I wanted to play a small part in that. So that's why I chose it.
Love the innovation angle. It's true.
Yeah, I'm going to be a little bit more specific here. Like, why did I choose quantum technologies and quantum engineering? So you may or may not know that quantum mechanics is a completely different way to describe reality than what we are typically used to see. So the fact that we could engineer quantum systems to, recreate and study quantum effects, I found really profound. Like the fact that you could do it with your hands and like test them and like access this dimension of reality by engineering system, I found really cool. So that's why I chose quantum technology.
So I guess I just found fundamentally quantum mechanics really interesting. And at some point I decided I want to know a bit more about it and get my hands dirty.
Right, great answers there. So if I had to summarize it, it would be the curiosity behind quantum mechanics, which still blows my mind. I watch videos on it. It just hurts my brain. But I also really like the innovation angle that, in scientific discovery, so much has been discovered. And if you want to be a pioneer, you almost have to be at the forefront of emerging technology like quantum. So yeah, great answers there. I've got another question here, and I'm going to pose it to Zishin and then Jason as well. And the question is, what quantum technology and future applications are you most excited about? So I know a few of you in the audience have asked for these questions. So I'll go to Zishin first, and then I'll go to Jason. Do you want me to repeat the question? So it's, what quantum technology and future applications are you most excited about?
So I guess a few decades into the future, we're going to have fully functioning quantum error corrected computers that can simulate chemistry, molecules, and drugs exponentially faster than classical computers can. Personally, I'm actually looking forward to somebody building my stuff that is using using a quantum repeater network to act as a giant telescope array. So, we can look at black holes and capture details around it.
So many different applications. I love hearing different examples. So what about you, Jason?
Yeah, so one of the things is that we don't really know what the future applications are going to be fully. When people made the first computers, they weren't really thinking of the internet, of mobile phones, Netflix or Google or any of that. But to give a concrete answer, I'm quite interested in the applications in cryptography and also for chemistry simulations that might revolutionize the drug and pharmaceutical companies in a really positive way.
Love it. Love the different applications there. So you've got space, black holes, and you've got medicine and drug discovery. Amazing. I'll go to Jacinta next for the next question. And Jacinta, this is really touching on your experience as a summer research scholarship student at the USQA. And my question is, how did it have an impact on your study and career path?
Yes, it's a great question. So just to clarify, for my SQA Summer Research Scholarship, I did it at UNSW rather than USyd, and the impacts of that have definitely pointed me in towards the direction I want to go for my PhD and future work. So I did it in Professor Hamilton's lab at UNSW. We were working on topological materials, topological qubits rather. And I know now, after doing that 6-week scholarship outside of my immediate bubble in USyd, was enough to convince me that that's what I want to do, topological qubits in the future. So yeah, that'd be it.
Great. So there you go. You can decide your career path in an undergraduate pathway in a summer scholarship. I'm going to go to Irene now for this question. So Irene, how have you found the move to Sydney as an international student? And what did you find helped forming the connections in the Sydney quantum community?
Okay, so moving from Europe, it's an interesting experience. Just going to Australia is a whole different world, so far from home and so different. But I think, yeah, what really helped, and to be honest with you, was SQA, like building, you get to really meet and hang out and talk science with all the different universities and like people that are participating in research in all the different universities. And also SQA provides, it's just a lot of networking that SQA opened up for us. And it was truly through it that I was able to connect with the quantum community in Sydney.
It's been great having you, Irene. And Irene was one of our first PhD students when we established in 2020. So she's been here for the whole ride. So I might go to Jason again. This is a very specific question. This is based on some questions we've gotten from the online audience in the registration. This one is computer science versus physics and the path to quantum. Would you be an experimentalist or a theorist?
It's a good question. It really depends on what your interests are, and they are fundamentally different fields. From my experience, physicists and theorists are always clashing heads, but it doesn't really need to be like that. You can sort of dip into a little bit of one and a little bit of the other. And I think the people that can navigate both worlds, they can sort of bring them together, and then we can have more productive conversations and perhaps more practical research when everybody actually comes together and has a cohesive movement forward. Because usually, theorists will be like, we want this, physicists will say, we can do this, and there's a little bit of a disconnect there. But if you can bridge that, then, you can go places.
Love that answer. And I love that everyone's smiling when you're like, there can be a disconnect sometimes. So everyone's experienced, I guess.
Yeah.
Now I'd like to encourage you in audience, in person, if anyone has a question, and there's no stupid questions, raise your hand. We have some mic runners. If you have any questions, otherwise, we got a question at the front here. So the question was, are there any domestic, anybody want to, Zishan will go.
So I guess we're still in a much infant stage for quantum technologies at the time, right now. There are startup companies starting to sell quantum technologies. So quantum cryptography, so quantum key distribution is quite a mature field, and there are companies based in Australia. I guess what every country is afraid of is being left behind in the quantum race. So you've probably heard of the tension between US and China. So China sent up a quantum satellite that kicked off an entire US national initiative. And we're beginning to see some of that happening here in Australia. I guess we're watching to see what happens.
That's a very concrete example. We have some of those startups working on quantum cryptography, quantum key distribution, actually here in the quantum terminal. So it's a great place to be to learn quantum, to start a business here, and to see what's happening in the Sydney and Australian scene. We have another question here in the room out back.
So do you think that quantum computers will eventually replace regular computers, or do you think they'll replace them in specific settings, or do you think they'll function more as a separate unit used to augment specific processing capabilities of regular computers?
Yeah, I'll take that. I think the last option is probably the most relevant. They'll probably act as sort of an augmentation where it'll be a separate processing unit. Nobody really knows exactly what the quantum computer will look like in 20, 30 years, but it will be able to accelerate certain workloads for certain problems. And you could definitely foresee some sort of hybrid where classical computing will never be completely replaced by quantum, but there will be things which quantum computing will be a lot better at. And you'll be working with both processors to solve certain problems in the future.
So classical computers aren't dead. There you go. Another question here.
Firstly, thank you, STO, for having this, and thanks to the panelists for your time. My question is for Jason. I wanted to know, what is your day-to-day like working in algorithms and architecture? And what sort of background reading would you recommend to get a better understanding of that specific subfield?
Yeah, so when I started off, I only knew sort of like the fundamentals of some maths and computer science and stuff like that. To get myself up to speed, to actually start my quantum journey, I read some quantum textbooks. Nielsen one is a very famous one to start with, and also just some cutting edge research in the area. Just searching online on the archive for lots of different papers, and sort of went along that route. What my day-to-day life looks like is, for me specifically, it's lots of programming, lots of time in front of a computer, lots of time in front of a whiteboard, whether it's trying to sort out a certain mathematical problem, whether it's going through some theory and some mathematics, whether it's debugging my code, which isn't working. It's usually, but that's my day-to-day, I would say. Yeah. Me specifically, I use a lot of Python. That's also just to glue everything together, but also for a lot of the simulations. I also use C, which, it's quite fast, low-level programming. And then I also use some of the quantum programming languages like Q#, like Circ, and those sort of things. So yeah, they're all quite important skills to pick up.
All right, we have probably time for one or two more questions. I'm going to go. Oh, okay, we've got one more in the audience here. Yep, sure.
Yeah, so my question's for Jacinta in regards to the scholarship. What sort of, like, do you have any prior knowledge, practical skills to be able to, go do that program? Like you mentioned that you designed a circuit and fabricated yourself. Was that something you knew before, or could someone go in and sort of learn that stuff from the program?
Yeah, that's a really great question. So before I did do the SQA scholarship, I had actually already been trained in fabrication and all of the skills that you actually need to build a quantum chip, which I admit is very unconventional for an undergraduate of my years. And that came in very handy during the scholarship because I was able to compare processes between both fabrication facilities at UNSW and at Sydney. That was part of my project, actually, working on certain levels of the fabrication chain. But conventionally, for an ordinary undergraduate scholarship, it's only 6 weeks. You have absolutely not enough time to get trained in fabrication. That sort of thing takes, 9 months, a year even, to be able to do that effectively. So personally, I did, but I'm saying that you don't need to. No, I wasn't as part of my degree. No, sorry, this was separate to my degree. Yeah.
Yeah, and with these 6-week projects, you can do so many things. Fabrication is only one aspect of it, and generally you will get your hands dirty with some kind of application. Probably won't, be an advanced fabricator, as just that it takes some time, but you will be able to have an introduction to it. We'll just go to a question from the online audience, and that question was, what's your advice for someone in high school? How can they learn more about quantum? How can they get prepared? And I'll kick this answer off. Do some research, go online, look up as much stuff as possible. And there's programs, there's summer camps. Get in contact with us. We have lots of initiatives coming up. So keep in touch with us, join our mailing list. We have some initiatives coming up, high school students. But I'll go to the panel.
I'll kick it off. Just because when I was in high school, that was when my sort of love for quantum computing did flourish. There is so much out there. So please don't be afraid to go even asking the professors and actually talking to them. They are more than happy to talk to you about anything you want in quantum computing, particularly about their field. If you're enthusiastic enough and if you're keen enough, they want to talk to you about it. But there are so many resources available on the internet now. Even when I was in high school, since then it's progressed a lot more. So there's MIT OpenCourseWare and a million other things that you can actually go to, as Asa said. So please just keep your eyes open. Don't be afraid to ask people and reach out to do things that you might not otherwise have had the opportunity to do. There are opportunities everywhere.
I would also say, if you're interested, our website does list all of our academic experts. And as the panelists have said, they're more than happy to answer your questions and to talk to you. So if you're interested, if there's some area that you're particularly interested in, look on our website. We can help you get in contact with some of these researchers. And we've got time probably for one more question in the audience.
I'm just wondering, what do you hate, or what are your pet peeves about quantum and stuff?
I think what's most stressful is that things go way slower than you wish. So like as an experimentalist, like when you're working, making these chips and trying to make it work, it actually takes more time than you expect. So it's just that frustration of wanting to get there, but like it's a slow process.
There's no undo button in the lab. If you break it, it's broken.
So that wraps up the panel and the Q&A panel. So thank you so much to our excellent panelists. It's been so interesting hearing your journeys. I hope you've enjoyed hearing them as well. And so look, we didn't get to get through all the questions. So I encourage you, please get in contact with us, email us, send us your inquiries or questions, and we'll get back to you. Also, there might have been some, if you had so many issues with the Zoom and seeing the stream, we will have a recording available. We'll be sending it out to all registrants who can watch it again. But otherwise, thank you so much for joining us online and in person, and we hope to see you soon.